Welcome back everybody, my name is Dustin. So we already have our window and project started, so we should be able to easily create our first triangle with a little bit of work. So in this video, we're going to quickly go over how to make a triangle, how to make a quad, and if we have time, how to load and use a texture. I'm not going to go into too much depth here. It's more to just get our feet wet. However, if you're looking for some more information on OpenGL, there are some great resources out there like learnopengl.com. Or Mike Shaw has an awesome introduction to OpenGL. You should check that out on his channel. With that in mind, let's quickly go over some of the things that I would like to cover in this video. Alright, so let's look into drawing stuff because that's really what we want to do with OpenGL. So we're going to go over some vertices, shaders, and maybe textures. Let's see how that goes. In order to draw anything in OpenGL, we're going to need vertex data. Vertex data is usually based on 3D coordinates. So there will be an X, Y, and Z value. But we'll be doing 2D, so we'll just be setting the Z coordinates to 0. We'll also be grabbing a handy math library to help us, GLM, or OpenGL Mathematics Library. To store the data, we're going to be using the Vertex Buffer Object, or VBO. These are used as source values for vertex arrays or vertex array objects. The VBO stores the vertex data and uses the source values for the vertex array. What is the vertex array object? The VAO stores all of the state and format of the vertex data and the buffer objects. We will have to generate the vertex arrays and the vertex buffers in order to use them. The basics functions for that are GL gen vertex arrays. That takes in a size, GL size I, and our GL uint pointer of arrays. The N specifies the number of VAO names to generate, and the arrays specifies an array in which generated VAO names are stored. There's also GL gen buffers. That also takes in the size and the buffer. Once the vertex array and buffer object is generated, we have to bind them. And we bind them using GL bind vertex array, GL bind buffer, and then after the buffers are bound, we want to buffer the data. So let's talk a little bit about shaders. A shader is a user-defined program that is designed to run in the GPU. In OpenGL, the shader language is GLSL. The shaders that we care about are the vertex shader. This handles the processing of individual vertices and gets its data from the vertex array. It also performs various transformations. However, we'll get into that in other videos. It also defines the attribute index or the layout location of the vertex attributes. Right now, we only really care about position for our vertex, but we'll get into more other things later on. Like when you're using a texture, you're going to have UVs as well. And we'll talk about that when we start getting into texture. Then we have the fragment shader. The fragment shader calculates the color of each fragment that the user sees on the screen. It also outputs a depth value, possible stencil values, and any color values that it may have. So here's an example of some simple shaders. So the vertex shader, as you can see here, you have the layout location, and we're taking in a vec3, and that's your position of your vertex. However, the GL position needs a vec4. So we just send in our A position here, and then just put in 1. The fragment shader outputs a color. In this case, we're outputting a vec4 for each pixel, and each pixel is going to have a pink color with this particular arrangement. In this video, we'll just be making these strings, but in later videos, we'll actually be creating our own shader files that we will read in. Alright, so let's get started looking into the code. Alright, in the last video, we had our projects made, and we were able to open up a window. We'll just open that up real fast. See, then we got our window open right there. So what we want to do now, let's change that to not be blue anymore. So we'll just change our clear color. Let's change it to black. Cool. So we have a black window right now. We can open and close it. So what we want to do now is get our vertex data. So what is our vertex data? So we're just going to have vertices for now. And we'll do that right here. Create temp vertex data. So we're just going to have, that's going to be a float, vertices, and we want this to be an array. So our first vertices are going to be 0.0, f, 0.5, f, 0. So this is one vertex. This will be one of our vertex that we're sending in. And then we'll have So what this is going to do, this will be basically the center of the screen. When you first start using OpenGL, it separates your screen into basically 4 quadrants. So you'll have 4 quadrants with the center of the screen being 0, 0, and it'll go from -1 to 1. So this right here would be halfway up, and then this way would be halfway down, halfway over, and then this one would be halfway over the other way. You get the idea. So now that we have our vertices, we can quickly create our temp vertex source. And that's just going to be a const char pointer vertex source. And here we're going to do that program for the vertex shader that you saw in the slides. So that's just going to be version 450 core, because we're using OpenGL 4.5. Then we'll have our layout, location, and that's equal to 0. In vec3, we'll call that a position. Oh, we don't want to do that. So this would be this here, vec3. So a vec3 of 3 floats, 1, 2, 3. So that's 1 vec3, or 1 vertex. Then we have void main. It basically looks like a C program, but it's its own little program with its own little things. Oh, I hit that again and again. 1, 2, 3, 4. This is GL position equals vec4 a position 1.0. All right. So now that we have our source, did I make any mistakes? Yes, I did, right there. Now we can create the shader. And that's just going to be GLUint vertex shader and vertex shader is equal to GL create shader, and this is a vertex shader. Now we want to add the vertex shader source. And this takes in the shader, the count, the string, and the length. We don't need to send in the length, but we do need that string. And it's a pointer. Vertex source, null. And once we've done that, we want to try to compile the vertex shader. So let's compile the vertex shader. And that is just GL compile shader, and we just send in the vertex shader. Now we want to get the status of the compilation, and we'll just say int status. Let's get rid of this. And that's just GL get shader IV vertex shader GL compile status, and then we just send in our int. Then we go if not status. Now we just want to, now we want to get the info log. Oh, we'll call it, yeah, we'll say info log get shader info log, and we want to do this so we can see why it failed to compile. null length, and we just want to send in the info log. So we want this error to go to our console because we want to see why it failed to compile, so we can go in back and fix it. But we don't want to keep going, so we just want to return -1. All right. So that should be good for our vertex shader. So now let's create a temp fragment shader. So it's basically the same idea. We can copy all of this and make changes accordingly. Get rid of that. Not sure if this is going to be faster than just typing it all out. We don't need this whole line. And we'll say out vec4 color void main color is equal to vec4, and you can color this whatever you like. I'm going to color it pink. All right, that looks good to me. So right here, let's change this to fragment shader. Copy that. Change this to GL fragment shader. Shader source, vertex fragment source, fragment. Now we have to compile the fragment. All right, that should be everything we need there. See if I missed anything, fragment. All right, that looks good. So now we want to create the shader program. And that is just GLUint shader program. Shader program is equal to GL create program. After the program is created, we're going to want to attach the above shaders. And to do that, we just do GL attach shader, shader program, vertex shader, and do it again with the fragment shader. Once they're attached, now you're going to want to try to link the shader program. So now we want to link the program. GL link program, shader program. Once you've linked the program, you're going to actually want to get the status. So check the link status. GL get program IV. Before it was get shader IV, and now we want to send in the shader program. And we want to see GL link status. And send in status again. And we can probably just copy this here. Now I can't remember, is GL get program info log? Yep. And shader program. Failed to link shader program. All right, so now we can enable the shader program. All right, so now once the program is created and linked, we don't need the above created shaders anymore, so we can actually delete those. So once the program is created and linked, you can delete the shaders. Now we're going to have to create the vertex array object. And the vertex buffer object. And we can do that like this. GLUint, VAO, VBO. And now let's generate the VAO. Now, we all want to do the same thing, but we don't want to generate the VBO. Gen buffers, 1, VBO. Now we're going to want to bind the VAO and bind the buffer. Now, when you're binding a buffer, it takes in a target and it needs to know what type of buffer it's going to be. So it's going to be a GL array buffer, and we're setting in the VBO. After we bind them, we want to buffer the data. And we buffer that data by going GL buffer data, or data, I don't know how you say it. So same with this, so this one's going to take, this takes the target as well. So GL array buffer. This is the target buffer type. Then we have the size of vertices times, there's 3 times size of float. So this is the size in bytes of the buffer objects new data store. And we're going to need a comma here. And then we're going to send in the vertices. And for now, we're just going to do GL static draw. And we'll just put a little comment here, a pointer to the data that will be copied into the data store. And then this the expected usage pattern of the data store. All right. So now that the data is buffered, we must link the vertex attributes. Right now, we only really care about positional data. So to link the vertex attributes, we need to use GL vertex attrib pointer. And so what do we want first? The first thing is which attribute it is, or the layout position. So we're at position 0. That's up here. So if we go back to our vertex source, that's this here. And we're looking for a vec3 position. So let's go here. And we'll just put some more, we'll do more comments as well. Attribute 0, the layout position in the shader. And then there's 3. That is the size. Number of components per vertex. Right now we only have 3 components in our vertex, but this number can grow. GL float. This is the type. The data type of the above components. So the stride, it needs to know the stride so it knows how far to go for this particular component. So for this layout position of the shader, how big is its stride? So its stride is 3 XYZ floats, if that makes sense. So we need 3 times size of float. This also can change. Specifies the byte offset between consecutive attributes. Then after the stride, we have our offset or pointer. This could, I believe, could just be 0. Oh, sorry, I missed one. We need to know, is it normalized? And it's not normalized, so GL false. So normalized. And what is normalized? Normalized is specifies if fixed point data values should be normalized. Now, I've never seen that used. Other people may have seen it used, but I haven't seen it used for what I've been doing so far. And this takes a void pointer here, but I think you can just put 0 for the first, but we're gonna do it anyway. Void pointer. So we're just doing a C-style cast to a void pointer. And this is the pointer. And this specifies the offset of the first component. Right now it's at 0, so we don't care, but say we get UVs, so it'll be past these 3. So it'll be at 3. So once we have this, we can now enable it. So we want to enable, so GL enable vertex attrib array, and that's at the index 0. Okay, we're almost done for that. So now after that, we're going to want to bind the buffer and vertex back to 0. So we're just unbinding these until we're ready to use it. All right, almost ready, almost ready. I think we're almost ready. So down here, we're just gonna make sure that we're using our shader. So GL use program, shader program, GL bind vertex array, that's VAO. And now let's draw the triangle. GL draw arrays, and we want to draw GL triangles, and that's where do we want to start? 0, so no offset, and the count 3, so there should be 3, and let's see if it works. Oh, build errors, status redefinition, that'll do it. Try again. Didn't show anything, and no errors. Not good. Oh yeah, so I found the issue. The issue was something silly, and it was this here. Now, this is taking the position of the actual window, so if we run this, it's like where this position is, not the position in the window. So we don't want that. So we want to get rid of that, and we actually just want to set this to 0, 0 for now. Not window.0, so 0, 0. And then run it. That should work. Yay! So there's our triangle right in the middle of the screen. So I also added this here just to unbind the vertex array. So that was nice, that was dandy, but we can also draw a quad. We'll quickly draw a quad. So to do that, we just got to make a few changes. We'll leave this for now. And so now we want to create vertices for a quad. So that's just float, vertices, and we're gonna have our first triangle. And that'll be 0, 5. And that's top left corner. That'll be bottom right corner. Then it's and that'll be bottom left. And then we'll have our second triangle. So this is, move those over, the same as this one. So it's bottom right. Sorry, this is wrong. This is top right. Bottom, this is top left. There we go, yeah. Sorry, I'm getting confused. Now this is bottom left. And this is top left. As you can see, these are sharing two. This and this. This and this. These are shared. top left, bottom right. I believe that's all we have to do for that change. But we do have to change this down here to 6. And I think this, let's try to run it, see. This might have to be changed as well. Nope, there we go. There's our square. But if you look at our square, or our quad, it's not really a square, it's more of a rectangle. And that has to do with the aspect ratio, or the window. So if we change our window to be the same, it'll actually be a square. So let's go, where do we create our window? Right here. So if we just change that to 480, it'll be a square now. So you see now it's a square, because OpenGL doesn't care about the size of your window. It just splits it into 4, with 0 being the origin, and each side being from -1 to 1, -1 to 1, or -1 to 1. So if the window is wider than it is high, you'll end up with a rectangle. There's a way to deal with that using transformations and projections, but we're not going to get into that right now. We're going to get into another video. So we have our quad, but if you see right here, we're using the same vertices multiple times, right? So we're using the top left twice and the bottom right also twice. Now there's a way around this, and we can use something called an index buffer object, and that'll allow us to use indices rather than using more vertices. We will be using indexes or indices, but they're much smaller in size compared to a vertex. A vertex can hold much more data. Your 16-bit index is 2 bytes, but you could have many bytes more in a vertex, so we're saving in space that way. A way around duplication of vertices is to use an index buffer, and we can do that by doing this. So we go GLUint indices is equal to, so which ones are we going to need? We need 1, 2, 3, or 0, 1, 2, and which ones are used more than once? So 2 is used, and this is used. So we can go 2, 3, 0, and then we can get rid of this, and we can get rid of this, and we can just change this around a bit. Cool. So now we're just using the 4 vertices rather than 6 vertices, and this saves on space and can be faster in some cases. However, once we do that, we need to create an element array or element buffer object. And we do that the same way as doing the other ones. So right here, and we'll just call this the index buffer object. Down here, so we can basically do the same thing here. Copy this. We don't need this here. This has to be changed to GL element array buffer IBO GL element array buffer. So everything is basically the same, except for this here. We actually want, get rid of this. So when we're buffering the data, it is actually 6 times size of GLUint, because the type has changed as well, and we're using indices instead. And then we can do GL element array buffer to 0. Then down here we have to do something else. We can't use draw triangles anymore. We'll be using GL draw elements, and that's still GL triangles. then the count for this will be 6. And the GL enum type, well, what type is this? These are unsigned integers, so it's GL unsigned int, and all right. I don't think I'm missing anything. Let's just try it. Of course. IVO. Yeah, that's silly of me. So we also need to gen GL gen buffer 1 IVO. Oh, of course. All right, so if we take those out, there we go. Now that is using our indices and our vertices, and it's working the same way. All right, so this video has gone on long enough, but in the next video, we'll look into loading textures, UVs, and get a simple camera working so we can move around and scale. Hopefully you enjoyed the video. If there's any suggestions or tips and ways that I can improve the video, please leave a comment below. Other than that, see you next time.